Welcome viewers, in this video we will see the solved problem based on the resonance circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the statement. A coil of resistance 40 ohm and inductance 0.75 Henry form a part of series circuit for which the resonant frequency is 55 cycles per second. R and L is connected in series. Further, the resonant frequency is given. If the supply voltage is 250 voltage, 50 cycles per second, find the first one is line current, power factor and voltage across the coil. So the given data R equal to 40 ohm, L equal to 0.75 Henry, F naught equal to 55 cycles per second, resonant frequency. The supply frequency 50 cycles per second, applied voltage is 250 voltage. Now from this given resonant frequency, we know the formula F naught equal to 1 divided by 2 pi square root of LC. Square on both the sides, so F naught square equal to 1 divided by 2 pi square is 4 pi square. Square root of LC is LC. Right. Now from this we can able to find the C value. C value is not given. So we can able to find the capacitance value. So see this R and L is given but C value not given. So bring this C this side and F naught square that side in the denominator. So C equal to 1 divided by 4 pi square F naught square L. So all these values are available. 1 divided by 4 into pi square, F naught is 55. 55 square, L value is 0.75. So from that we are able to, by simplifying this, we can find the C value. 11.16 into 10 to the power minus 6 farad. So the C value is available. Now we'll be able to find the XL and XC, inductive reactance and capacitive reactance. We know that XL equal to 2 pi FL. So 2 into pi into F is 50, supply frequency 50 into L is 0.75, is not 7.5, is 0.75. So while simplifying we will get 235.6 ohm, the inductive reactance. Similarly, capacitive reactance Xc equal to 1 divided by 2 pi Fc, that is 1 divided by 2 into pi into supply frequency 50, the capacitance what we calculated 11.6 into 10 to the power minus 6. So while simplifying we will get 285.2 ohm. Right. So from this XL and XC we can able to find the impedance of the circuit. Impedance Z equal to square root of R square plus XL minus XC the whole square. It's a general formula. R value given 40 square. XL what we calculated 256.6. XC is 285.2. 235.6 minus 285.2 the whole square. So while simplifying we got 63.72 ohm capacitive. Right, it is coming under, because of this value is a capacitive. So the impedance value we calculated. So from the resonant frequency first we calculated the capacitor value, then XL, XC, finally impedance. So from this value we can find the required data one by one. The first one is the line current. We need to find the line current. Line current, the magnitude of I equal to magnitude of E divided by magnitude of Z. Right, all are magnitude. So the supply voltage is 250, Z what we calculated 63.72. So while simplifying we got 3.92 amperes. Right, the line voltage, the line current is calculated as 3.92 ampere. Similarly we can able to find the power factor. Cos pi equal to R divided by Z. R is 40, Z is 63.72. So it is 0.628 leading. Power factor is leading. Next we need to find the voltage across the coil. So first we will find the impedance of the coil, then we will go for the voltage across the coil. Z coil, impedance of the coil equal to R square plus XL square. That is equal to square root of 40 square plus 235.6 square. So what we already calculated. So the Z coil is 239 ohm. So from by using this we can able to find the voltage across the coil. E coil, voltage across the coil equal to magnitude of I into magnitude of impedance of the coil. So I is already calculated 3.92 into impedance of the coil is 239 what we calculated. So by multiplying these two we got 937 voltage. So finally we calculated the voltage across the coil also. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.